This is the video replication file for Lecture Prep 9 from the St. Louis University course, Introduction to Geographic Information Science. In this lecture prep, we're going to look at several different ways for mapping the entire world, several different projections. So we'll start with a blank map document here, and under GIS tutorial, we want to open up the Maps folder, and we're looking for the map name Tutorial 5-2. When we open it up, we'll close the catalog so that we can have as much space as possible for the map. This is a map of the world projected using the WGS 1984 Geographic Coordinate System. So this generally conforms to how we think about the world, but you'll notice Antarctica down at the bottom is spread out very, very widely. So what we'll do with this lecture prep is make some changes. Instead of using the WGS 1984 Geographic Coordinate System, we'll look at a number of projections for worldwide data. To start making changes, we'll right-click on the Layers data frame, go to Properties, and then choose the Coordinate System tab in the Properties window. We'll see WGS 1984 highlighted here. This is the current geographic coordinate system. And if we want to make some changes, we can scroll up in the window and hide or shrink all of the geographic coordinate system options. Instead, we'll choose projected coordinate systems and go down to the world folder. And in this folder are a number of different projections that we could use to map the world, such as the famous Mercator projection. To switch, we highlight the projection we want, click Apply, and then click OK. We might have to rezoom the map to the full extent because the projections will change the geometry significantly. And here we see that famous Mercator projection where Greenland infamously is seen as just as large as Africa, even though it is significantly smaller, and Antarctica dwarfs the rest of the world, which of course is not an accurate depiction of the size of these different land masses. The last part of the lecture prep involves selecting two of the other projection systems indicated in this part of GIS tutorial. So to switch, we'll right-click on the Layers data frame again. We'll go down to Properties. And in the Coordinate Systems tab, we're going to move our mouse up to the hammer ATOF projection. Click Apply and OK. And then zoom to the full extent again. And here we see a significantly different projection of the world. This privileges equal area. So the cartographic property we are interested in ensuring is most accurately represented is size here. That the relative area of each of these different features should be correctly displayed. And so Greenland now looks much, much smaller than Africa, and Antarctica is in a much more proportional place on the map. We're going to look at one additional projection here. And so to make that change, again, we'll move our mouse over to the Layers data frame. We'll right-click on the data frame and choose Properties. And then we're going to scroll down to the Robinson projection. Highlight Robinson, click Apply, and OK. And the Robinson projection is a compromise projection. So it does not privilege one characteristic of a worldwide projection over others. And this is something we'll talk more about in class. The goal of the Robinson projection is to be as generally applicable in terms of area and scale and distance as possible for mapping the world. So the Robinson projection is an excellent choice for creating worldwide thematic mapping. And it was used by National Geographic and the Rand McNally Atlas Company because of its general applicability for worldwide mapping.